Hello students, class 8 once again. I am Sudhi and welcome back to my video. In today's video, I will show you the next portion of the chapter number 13, that is inverse proportion. So before we have discussed about the direct proportion, so in direct proportion, you see that the value of y is increases when the value of x is increases. Once again, in direct proportion, when the value of x is increased, the value of y also increases. Okay. So therefore, what happens? They keep on increasing the value when one value is increased, another value also increases. Once again, see in the direct proportion, when the x value is increases, y value also increase. That is in the direct proportion. Okay, in the direct proportion, in the direct proportion, not direction, in the direct proportion, when the value of x is increases, then the value of y also increases. Okay. So what happens? This is called direct proportion, but in inverse proportion, when the x value is increased, then y value will be decreased. Inverse. Inverse means something opposite. Okay, opposite. Here in the direct proportion, x value increase, y also increase. But in inverse proportion, when x is increased, y will decrease. Y value will be decreased. Okay. So this is called inverse. Inverse proportion. Inverse means something opposite, something which is not like. When one is increased, other is decreases. Once again, another case is there. If x is decreased, y increase. This is also another case of the inverse proportion. Inverse proportion. Okay. So this means vice versa. This is called vice versa. Vice versa. Means when one is increased, one is decreasing. When another is decreased, the other value is decreased. So this is called the inverse. So therefore, their proportion is called inverse proportion. But for inverse proportion also, the value of x into y is always remain constant. Means x, y also will be constant, and therefore the relation of the inverse proportion of this value y and x and y remain constant, and we say that x y is equal to k. K stands for constant, and therefore a relation is there of the inverse proportion of this x value and y value, that is x1 y1 is equal to x2 y2. Okay, so this is the relation. A relation is there, okay, of the x value and y value if they are inverse proportion. If they are inverse proportion, x into y will be remain constant. Okay, x and y will be remain constant, x into y. The product of x, y will be remain constant, and there is a relation. There is x1 y1 is equal to x2 y2. Means the product of x1 y1 and the product of x2 y2 will be same. So this is the relation. Okay, this relation we have to be remember, and we have to by heart. You have to keep in your mind while doing the inverse proportion. Inverse proportion is in that if the proportion is inverse. Inverse means you know that if the value of x increase, y will be decrease, or if the x is decreased, y value will be increased. So this is called the inverse. So if the value of x and y is in the inverse proportion, then they have a relation that is x1 into y1 is equal to x2 into y2. That relation you have to remember. In direct proportion, there is x1 y1 is equal to x2 y2. Isn't it? This is for the direct proportion. But for the inverse proportion, x1 into y1 is equal to x2 into y2. Okay, the product of x1 y1 is equal to the product of x2 y2. That is the relation of the inverse proportion. Okay, so with this only then we can start our new exercise, that is 13.2. Okay. So here we discuss about some examples of the inverse proportion. So here is one question. 6 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of same type are used? See, kind of situations are there in our life that used to be an inverse proportion. For example, a certain work of the day is there. Okay, so that work is used to be done by 5%. So if we deploy means if we have 10% to do the work, then the work will be complete in half of the day. The work that used to be carry on or will consume the whole day, if we increase the number of workers, then the time will be less. This is the one example of inverse proportion. Okay, clear. And once again, see, if you study 2 hours, you can complete one chapter. If you study 2 hours, you can complete one chapter. But if you increase the time, then you increase the number of chapters, and it goes to the direct proportion. Number of time increase for study, the number of chapters completed. That used to increase both the values, isn't it? Time value also increase, and the value of the chapter also increase. Number of the chapters also increase. That means it is direct proportion. But inverse proportion is that, suppose if 1 kilo of rice is there, that is used to be consumed by 3%. 1 kg of rice is consumed by 3%. If you decreased again the rice, okay. So if 3% can consume the 1 kg of rice, if 4%, and if you increase the 4%, but what happens? The amount of rice, okay, that will be getting by the 1% will be decreases. 1 kg of rice is there. So 3%. Let us say 4%. 4% can consume the rice. Okay. So so a certain amount of rice will be getting by each of the person, 4%. But if you increase 5%, okay, from that 1 kg of rice, what happens? The amount of the rice will be decreases for per head, for per person, isn't it? Because you have to divide 1 kg to the 5%. Dividing 1 kg in 4% will have a certain amount, but if you divide the 1 kg of rice, if you divide the 1 kg of rice in 5%, then the amount will be decreases. You see, this is another example of inverse proportion. Okay, and some other cases also there. For example, one apple is there, isn't it? One apple is there, so this apple is going to be divided among 3 friends. So how much that parts they get will be different if there is 4% or if it is 5%. So it's what happens when the number of persons increase, then a certain amount of the rice or a certain amount of the apple, the piece of the apple become decreases, isn't it? So when one value is increases and another value is decreases, so this proportion is called inverse proportion, and this is an example of the inverse proportion. Like this, we have one situation here. That is, 6 pipes are required to fill the tank in 1 hour 20 minutes. So how long will it take if only 5 pipes of the same type are used? See, 6 pipes were used before, isn't it? And it takes 1 hour 1 hour 2 minutes. 1 hour 2 minutes were there, isn't it? 1 hour 2 minutes are there. So what happened? If this number of pipe is less, okay, less 5 pipes only, isn't it? Only 5 pipes are there. So how long it will take? So you just can imagine that 6 pipes takes 1 hour to 2 minutes. But if the number of pipes decreases, then the time taken will be more, of course, isn't it? For example, 5 men can do that work, isn't it? In 1 hour, 5 men can do a job or a work in 1 hour, but if you decrease to 3%, then that work will take more time to complete. The same way, isn't it? So the work done by 6 pairs is 1 hour to 2 minutes, but the work done, the work done by the 5 pairs will be again more. I mean, will be less. It will take more time, isn't it? So let us see how we can carry on. So for example, we are going to draw the table value. Okay. So first one, let us say that this is x value, this is y value. Okay. So x value, in the x, let us say that it is number of y. Number of y. And here time. Time in minutes. Because minutes is fraction is there, isn't it? It is minutes. So let us convert the hour also in minutes. Now, if the number of y is 6, it takes how many hours? How much the time? That is 80 minutes, isn't it? Yes, 80 minutes. There are 60 minutes in 1 hour and another 60 minutes, 2 minutes are there. I mean 20 minutes are there, okay? Not 2 minutes, just 20 minutes. Yeah, so altogether 80 minutes are there. Then next, if it is 5, then we are going to find out how much the time will be taken, isn't it? So absolutely that the capacity of the pipe will be more, that means it will take more time, isn't it? By 5, the capacity of doing the work by 6 will be more than the capacity of the work done by the 5 pipes, isn't it? Means it will take more time here. The time taken by the by 5 pipes will be more than the 6 pipes, because we are going to use less pipe, isn't it? And it will take more time. So how much it will take? Let's see. Whether it will take more time or less time, we can find out here. So we have the relation that the inverse relation, the inverse proportion relation says that x1 y1 is equal to x2 y2, isn't it? Implies that x1 is 6. Now 6 into 80 equal to, now x2 is 5 now into y2. Now we are going to find out this y2. Actually is y2, isn't it? Yes, y2. So y2, how much the y2 is there? Let us see. So therefore y2 is equal to 6 into 80 divided by 5. Right. You can say this, isn't it? Yes. 5 1 is 5 and 5 6 the 30. Yes. Now we can here 6 into 16. 6 is the 36 here. We have 96. So 96 means. So 96 means. That means here the time taken by 5 pipes to fill the tank is 96 minutes. So you see here, when the value of y is decreased, the value of x is when the value of x is decreased, then the value of y increases. Right? Or when the value of y is increased, the value of x is decreased. Inverse proportion. Okay, this is called inverse proportion. Yes, right. So this is the answer. So let us see some more questions again in our exercise. Okay, so this is one example here. We will go to the exercise now. So my dear student, we have exercise 13.2. So 13.2, question number 1, 2, 3, they are logical questions only. So they are very simple also. So I think you can do that yourself. You can find a solution by yourself. So they are very simple. So just keep on trying them and put the question for your practice. Okay. So I want to leave this question 1 to 3 for you, and I will start from question number 4 here. Okay, clear. So I'll just read out question number 4 here. The question number 4 is asking that if a box of sweet is divided among 24 children, they will get 5 sweet each. So how many would each get if the number of students is reduced by 4? See, once again, if a box of sweet is divided among 24 children, they will get 5 sweet each. How many would get if the number of children is reduced by 4? So reduce, you see the word comes reduce here, the terms come reduce here. That means that it is an inverse proportion. So here in the solution, what we have to do, let us make one small table. Okay, tabulate it. We say that like this. Let us write here number of students. Okay, number of students. Student on the system. Children or number of students. Mathematics, you say children here. Children. So let it be the x value and here sweets. Okay, yeah, sweets. Sweets. How many sweets are there? That will be the y value. So here he said that there are 24 children. There are 24 children. So one box of the sweet is distributed among them. Each of them are getting 5 sweets, isn't it? Each of them are getting 5 sweets. Yeah. Then, if it is 20 students, so what will be the number of sweets for everyone? 24 students, 5 sweets, isn't it? If 20, then how many of them? Let us see. So here, you know that the relation we have is relation of inverse proportion. Inverse proportion, that is x1 y1 is equal to x2 y2. Implies that x1, how much is that? 24 into 5 equal to x2, 20 into y2. So we are going to find out the y2 here. Y2 is equal to y2, we are going to find out the y2, that means 24 into 5 divided by 20. Yes. 5 1 is 5, and 4 is 20. Then 4 6 is 24. We got here y2 is equal to 6. That means how many? 6 sweets. Isn't it? So therefore, each of the children will get 6 sweets if number of students is reduced by 4. By 4 means 24 students are there, then each of them will get 6 sweets. Okay, sweets per children or sweet per child. Okay. Yes. So this is the answer for question number 4. Now let's go to next question number. So hello students, next question we have question number 7. This question number 5 and 6 are also almost same as question number 4 and 5 are similar also, but too many questions I'm going to have, so later I do one in between. Okay, so since 5 and 6 you can just try yourself. They are very simple. Just follow that relations of the inverse proportion. Okay, nothing is just tabulate the informations, tabulate the value of x and y, and just apply the relations of the inverse proportion. That's all. Clear? So I'll just show this question number 7 here. The question number 7 is saying that a batch of bottles were packed into the 5 boxes with 12 bottles in each boxes. If the same batch is packed using 20 bottles in its boxes, how many boxes would be filled? See, actually one batch is there. Okay, one batch is there that it packed 25 boxes with 12 bottles. So and it is saying that if the same base is packed with 20 bottles, then how many boxes will be filled? For 12, see, they fill, they put 12 bottles and it become a kind of bunch, okay, bunch, 12 bunch of bottles. It comes out as 25 number of bunch. Bunch means group, you can say the pack, okay, pack. 25 boxes are there. So each boxes contain 12 bottles. So if it is contain 20 bottles, how many boxes will be there? For 12 boxes, for 12 boxes, 12, sorry, for 12 bottles, 12 bottles will fill in one and it used to get 25 boxes. If it is 20 bottles, okay, 20 bottles, then how many boxes will be there? The question is asked. So let us tabulate this first. So we make a table like this, okay, yeah, table like this, and so let us say this number of bottles, or you just can say bottles. So let it be the x value, and number of boxes, boxes. So it is y value. Okay. So here, if the number of bottle is 12, then there will be 25 boxes. And if the number of bottle is 20, how much the boxes will require, or boxes will be there. Okay. For one boxes, if it is filling with 12 bottles, 25 boxes will come out. If it is 20 bottles in one box, how many boxes will require or will be there? So we have the relation of inverse proportion. We know that, isn't it? Relation of inverse proportion is x1 y1 equal to x2 y2. Just apply this again. x1, that is 12, into y1, that is 25, equal to y2, that is 20, into, sorry, x2 20, y2 is 25 now, isn't it? Then what is that? Y2 we can find out here, 12 into 25 by 20. Yes. So let us see how much we are getting. So we get here y is equal to 12 into 5 by 20. So how much we are getting here? Let me see. 20 and 12. Okay. 6, 3, 2. 6, 10, and 5, 3. Got it? Yes. Yes. 4 3 12, 4 5 20. And 5 5 5 25. Now we get here 15 boxes. So therefore we have the answer, that is 15 boxes were required there if 20 bottles are there in one box. Okay. And this here we got here 15. So y2 value we get here 50, isn't it? So here you see when the number of bottles increases, number of boxes decreases. When the number of bottles decreases, number of boxes increases. It is called inverse proportion. Okay, vice versa. Then let us go to next question. So almost all the questions are same. We are just to apply this relation on. This is a very important relation that you have to carry on. First, you tabulate it. Okay, as the y value or x value of the given information. Then you apply the relation. That's all. Okay. So let us try one more question again. So my dear student, next question I just come after the 7 is 11. Okay. So question number 10 is I want to give you homework. Exactly you must try. Very logical and very say a little tricky question is there. Question number 10. I want that you try this question number 10. Okay. And if you have any doubt, you can ask me. But please you show that what you have done with the question number 10. Okay. In 11, 8, 9 is almost same as the others. Okay. So 11 also same, but I want to show this 11 here. See, a school has 8 periods a day, each of 45 minutes duration. How long will each period be if the school has 9 periods a day? Assuming the number of school hours be the same. See here in the table, what you are going to write is that you can just assume that here periods, okay, period of period will be the x and the time in minutes, okay, it is y. So first, when there is 8 periods and it's getting 45 minutes, 8 period for 45 minutes each, okay, and it is 9 periods, so how much the minutes will be, okay. So that means we have relation, okay, relation of inverse proportion, that is x1 y1 equal to x2 y2, implies that x1 8 into 45, okay, equal to 9 into y2. So y2 is equal to 8 into 45 by 9. Isn't it? So let us see how much we get here. So 9 5 is 45. So 8 5 is 40. If it is 9, if it is 9 periods of the school, that each period will reduce to 40 minutes. That means the value here is 40 minutes. So this is the answer. So question number 10 is little tricky. So I want to give this question number 10 as your homework and do and please submit me. Okay. I want to see each of you are trying this question number 10. Little tricky one and little logical question. Okay. That's why I want to give this for you. The remaining questions are same as it is. So this is the inverse proportion, my dear student, and here we have come to the end part of this chapter. That is direct inverse proportion. In direct proportion, the relation. Okay. In direct proportion, the relation is x1 y1 is equal to x2 y2. This for the direct proportion. Direct proportion. Okay. And inverse proportion, as you know that inverse proportion, x1 y1 is equal to x2 y2. So these relations are very important for you to find out the inverse proportion. Okay, clear? So here comes the end of today's session as well, and we'll meet again in next video. Till then, have a nice day all of you and take good care. Once again, thank you for watching this video. Bye bye.